Hello, good morning. This is Naz from NB Network Lessons. Hope everyone's doing okay and in high spirits. Quote of the day. One of my professors, while I was going to school in Alabama, once told me was that if somebody makes a mistake, do not make a big deal out of that. However, if somebody does something good, do make a big deal out of that. So think about that. So, having said that, date today is September 24th, and this is physics lesson 5, and we are discussing two dimension motion. We've already discussed uh, motion in x axis and y axis, which was one dimension. Now we're talking about two dimensions. So I do have a problem on the board where it says a meteor goes from 5 kilometer, 1.2 kilometer, these are the coordinates, initial coordinates, to 6.240 kilometers and 0.925 kilometers. These are the final coordinates. And the time it takes for the meteor to go from these coordinates to these coordinates is 1.140 seconds. What they're saying is that find the velocity in x and y direction. As you recall, in two dimension, let's say you have a projectile motion. I toss the baseball up in the air, it goes like this and comes down. So there is a vertical force and horizontal force pushing the ball, and this curved motion is the combination or is the mixture of vertical force and horizontal force. That is what basically essentially is the punchline for two dimension motion. Okay. So now let's go ahead and see if we can find the velocity in x and y direction. In other words, they're saying find the x component of the velocity and the y component of the velocity. Picture speaks thousand words. Let me draw a picture because that will make sense. So let's say we have, I'm not a good artist, but I will do my best to draw the picture. So we have x-axis and then we have y-axis. Okay. So let's say this is the point A. Okay. And the coordinates of this point are given 5 kilometers. And then we have 1.2 kilometers. Okay. In other words, basically what I'm saying is that X, this right here is 5 kilometers. Okay. And then in Y is 1.2 kilometers. Okay. So point B is, let's say, right here somewhere, I don't know, maybe right here. Okay. So this is point B, and the coordinates of that are 6.240 kilometers and 0.925 kilometers. Okay, let's call this A and let's call this point B. Okay, so basically your vector is going to look like this. Let me draw that in green. So your vector is going to be like this. Oops. Like I told you, I'm not a good artist, but I'll do my best. So from point A to point B, there we go. So this is how the vector is going to look, right? Okay. So now what they want is that they want us to find the average velocity in x direction and average velocity in y direction. Any ideas how we can do that? Pretty straightforward, easy peasy. What we do is that we say v average, okay, v average in x or with respect to x is equal to xb minus xa over delta t, right? Now this is what I'm finding is the force, or not the force, I'm sorry, the velocity in the x, which is pushing the meteor in the x direction. So what is xb? If you look in here, these right here are the x coordinates. So it's going to be 6.240 minus 5 divided by 1.140 second. So this is basically meters and this is seconds. And when you solve that, my friends, your answer is 1.09 kilometers. Sorry, this is kilometers. Kilometers per second. So how's that? Okay. Let's go ahead and see if we can find the coordinates in y direction. So find v average with respect to y. Any ideas? Well, basically it's going to be yb minus ya over delta t, right? What is yb? Yb is 0.925 minus 1.2 divided by delta t. And my friends, the answer is negative. Wow. Okay. Now let me explain you why we have this negative. Okay. So first of all, we know V average with respect to x is, we just found out, 1.09 kilometers per second. So the meteor is flying. It might even have curved motion. We don't know, but for simplicity, we are just drawing the straight line for this vector. So when the meteor is going up, flying up in the air and coming down, there is a vertical push and then there is a horizontal push. Okay, clear? So the vertical force or vertical velocity is 1.09 kilometers per second. That's the component. Even though your meteor is going like this, but the velocity in x direction is 1.09. Now, we average for y is equal to negative 0.241 kilometers per second. Now, a lot of students get confused about the negative signs, but I'm going to try to explain you, um, and I hope that you will understand because the concept is real simple. So, meteor is going like this, right? Okay, and then there is a horizontal push, and then we have minus 0.241 kilometers per second vertically going down. That's why we have this negative sign, because this push is horizontal and then it's pushing downward also. That's why you have v average y negative 0.241 kilometers per second. So that's all I have in this lesson. We've got a lot more in two-dimensional motion. In my next section, I'm going to come back and we're going to find the magnitude and direction of the vector. That's going to be pretty interesting. So stick with me. I'll come back and I'll teach you more. And if you like the contents, please go ahead and share as much as you can to your friends, to your family, anybody you think needs help, because sharing is caring. You take care of yourself, and I'll see you next time. Bye bye.